Yeah, well, I think you were well, it's well, let's discuss that. Unfortunately, that next year is just a question of you Thank you.
So hello everybody, and thank you for joining this second session of NMRG. So just to remember to all participants that this research group, so we are not targeting to standards but long-term research. Anyway, as a research group, we have the same policies, the same goal for our group, so the IPR and code of conduct. So just please be aware of that. We need a minute taker and JavaScript. Anyone here? The JavaScript at least, and I think everyone can take the notes as yesterday. Please one check with Java. Okay, thank you. Thank you both. Also, the bull sheets are circulating, so please write your name. And so the agenda is quite full, like for the first session, so we will try to really keep the time. And so for the presenter, we try to keep the presentation as expected in terms of time. And also for comments, please be concise. So this is the agenda, which is today, let's say, two topics. One is about talking about the reshuffling that we have started, and so you know, I see the last version circulating the last day. And also then we have some presentation of artificial intelligence for network with one actually technical presentation. Then we will have some presentation from other group working on that. We'll talk a bit about the challenge and some discussion that we have with the side meeting up here. So any comment on the agenda? Okay, so let's move to the. We have a comment on the agenda? No, it's okay. So let's move on to the chapter update. So as I said, so the version has been circulated. which was an update to the previous one that we already circulated. So the idea is not to completely redo the charter, but just to update with recent research activities we are performing or we want to perform in the group. So basically, we had kind of umbrella over this, let's say, new research activities, and this umbrella just represents the context in order to basically outline the three topics that we think that are important. So one is of course IBM, and we have already some work to do, and other is more related to cyber network and artificial intelligence. So for IBM, so intent-based networking, as you know, we have already several documents that are tied to the pipes, which is more, let's say, advanced. So there are a very specific work plan. So we have, for example, here you can see we have some items on the terminology, on the concept, on the taxonomy, but also on the architectural or life cycle parts that is already today reflected in some documents we have in the group. And then we have other items, which is also related to more practical content on practical aspects like the development, the interoperability of the tool, and the use cases. I will not enter into the detail here. Let's see if I think if you have comment there, we will be very happy to have it. And then we have what we call a work plan for cyber networks and AI. Maybe it's not a great term, but the idea here is actually to try to define what could be a roadmap for research in terms of AI for networking. And so really in the group, as we have already some activities around that, is more to use the group as a kind of incubator to, let's say, refine what could be a proposal. And so basically identify challenges that can serve as a future proposal in NMRG, in IETF, or somewhere else, we don't know. And also help together with the community. So in terms of next step, of course, we need feedback. So there are different questions here. Of course, that is that the work plan that we put here is what you would like to have in NMRG. And we also would like to know who would like to contribute in the different items, particularly the IBM work plan. We need people to work on that. And of course, it's time it's now, but also mailing lists. So let's go for questions now.
Dan Bogdanovich, it's more of a comment. I think we have a major network management architecture issue, as some of the concepts have not changed in over 20 years. And we are trying to use the existing architecture for all the new things, and we are hitting into different bottlenecks at different layers. Maybe rethinking some of the basic network management architectures, and maybe they're going against the controller agent architecture and try to see what other options could be a variant, because we are seeing a lot of the requirements and do those we are seeing a lot of new paths, but do those paths can be done on top of the existing ones. And I know from my own experience, we are running into many problems if you try to do basic autonomic system features with the existing network management architecture. It will be interesting to hear from the academic community if some of them are looking into new network management architectures. And I'm a little bit disappointed when I'm reading some papers or I'm seeing some proposals that we are just continuing with the same architecture that has been around for ages. It might be just me that I think that the architecture is becoming obsoleted and that we should be looking into new ones. But I'll be curious to hear from the community what is their opinion on, and do they see a need for a change or not.
Okay, so you would like to have this reflecting the discussion from Richard to see if we should also point out this topic.
Yeah, because I see a lot of problems in the network elements. I see how we are continuing to do, and there are certain imbalances that are creating major bottlenecks.
So we'll relay this comment to mailing list to our feedback. Thank you. Any other comments? Okay, so if there is no other, I think we can go with the.
Nothing at the back, so it's been a while to get to the microphone. So yeah, I mean, if there are interesting proposals for new architectures, that would be something that would be in scope for research. I think the plan to conclude the intent-based networking work is a reasonable plan. I would perhaps suggest that the rate of progress has not been perhaps the most energetic of the research groups we have over the last few years. So I would encourage you to try and make a focus on actually concluding that and publishing some documents and getting the work out. In terms of AI for network management, that's certainly a potentially a plausible topic for the future. I noticed looking at the agenda for today, we have one research presentation and then a bunch of reports from other organizations and challenges to stimulate research. I think if you can stimulate research, and if we're starting to see AI for network management research being brought here, then that would be a good sign for the chartering, for the rechartering. If we're simply seeing continued reports from other organizations, that's less of a good sign. So if you can stimulate research in that topic and show that there's a community and interest, then that's something we should consider for the chartering.
Okay.
As a very small side issue, I really would prefer if you used a term other than self-driving, given all the work on self-driving cars.
Okay, get the comment. Hey, this is Alex Clem. Just to comment or respond to Colin's remarks, just regarding, I see actually there's a lot of activity and research interest for AI in network management in other communities, notably IEEE Communication Society. And I think by having the charter here, so clearly there's a lot of work going on. So one question is basically how can we perhaps attract some of those communities and support to come here and believe and to for NMRG as a relevant venue for that. And I think having AI for NM as part of the charter, I think, is something that can help that. So I would actually support having this here.
Colin Perkins again. As I say, if there is evidence that there is a community being formed here to do AI work, then I would support you adding that to the charter. I don't think it's appropriate to add work to the charter with the goal of stimulating people to come here. I want to see that there is interest before I do that.
Okay.
Will from Huawei. So actually, I have an offline discussion with Jeremy about this work related to a network AI perspective. Given that because we have already have scheduled several presentations today on the other organizations' activities. So I would think that it's better if we can find some specific unique value for MRG to start this work. As I mentioned yesterday, maybe because we are so close to IETF and IETF is generating about the protocol specification. So maybe one of the unique value is that we can generate AI-based protocol specification or AI-assisted protocol specification. That will be our, unique value instead of working again, following the work from other, activities. That's my point.
Marie-Josée Montpetit, no chair hat, just me. Actually, I'd like to maybe as raising research interest, maybe we want also to look, not at what just AI can bring, well, how we can put AI in network management, but also how AI can help network management work in the network. There's a lot of network management that requires a lot of data. You need to move that data somewhere. How can then the network help the network management and not just, and the AI in terms of a reduction of data and everything, and not just add some kind of rule-based into network management, which was a lot of the stuff I've seen. But saying, okay, so knowing that we're gathering all that data everywhere, how can, and those are needed for the AI to work and for the AI in those network management things to work, but how can the network help that? So looking at it the other way around.
Yeah,
So
okay.
that's a comment.
Yeah, thank you for your comment regarding more the specificities of AI and the relationship with network management. I think we will, at the end, we'll have this kind of a wrap-up of the side meeting we have, and there are some related ideas too that Marie-José just expressed now. So I think we'll have more time to discuss a bit more on that aspect. So I think we have to move on to the next presenter. Andreas will be a remote on Miteco.
Yeah, hello.
Andreas, the floor is yours.
Yeah, do you hear me? Just a question.
You need to unmute at least somewhere because we see you speaking, but we cannot hear you.
Okay.
No,
so I got from Lorenzo, thanks for the support. I got the okay, the acknowledgement. Lorenzo tells me that you hear me.
Andreas, can you check if you are unmute on Miteco in your browser and on your laptop? Okay, so Andreas, the issue is not on your side, it's on the room side. There seems to be a problem from the Miteco audio stream in the room, so please be patient. Can you try again, Andreas, please?
Yeah, do you hear me?
Yeah, very good.
Okay, thank you. So I would say that starting directly. First, again, thanks to Jérôme, Laurent for inviting me and to have the opportunity to present parts of our work here. And I was also following now the introductory discussion about like terminologies and so on. So I will also use the self-driving part. So don't please so much upset. I think there are a lot of terms about what is AI and so on in networking. And we should really get to the core and discuss about that. So what I'm presenting is a kind of joint work I did together with some people here from TU Munich, but also from Vienna and also from Hungary. And so let's start directly. So can you go to the next slide? So that's all what we know about networks and still networks today. So the human is in the loop. And what the human is, of course, always doing is like monitoring the network, identifying thereby networking problems. And then when we have identified the problems, of course, what we are doing as humans is like we're trying to solve these problems. So we're optimizing the networks to get some solutions. And what is also there before we put anything into effect is that we are designing like the performance evaluation as well. So we think about, okay, this is our protocol, this is our algorithm, this is our architecture, and it should work like this, it should run like this. So we are also doing the testing. The problem here is that, of course, networks, that's all what we know, are getting more complex. So there is a clear need for this automation. So next slide. This is a picture what people always, or how people always see artificial intelligence and machine learning. So there's this ugly machine, this bad machine trying to replace the human. But what we believe is that I should more like on the next slide. So it should be your friend and your helper. It should augment your research. It should help you to develop the protocols, should help you to develop the algorithms. And then on the next slide. So next slide, please. We see that with AI or machine learning, the idea is to have self-monitoring networks so that the network itself can trigger the actions to identify problems. Then after that the network is actually equipped with opportunities or with actions to also self-optimize, to go towards the solution. And what I'm focusing on in this talk is the third part, which is about the self-benchmarking. So the network should also have some ways before putting solutions into reality or into effect that it can somehow self-benchmark and see how the solution it thinks is the best for the network should look like. So next slide. And what is the traditional way actually here? I mean, that's what we have in research. We have, for instance, the traces. We have sometimes we have the models. If we don't have the traces, so abstract from the traces, we have the models from the network traffic. And then if we want to try or test solutions, actually we are doing some kind of best guesses. So the human is also in the loop, and it's just like trying to select some points, some configurations, for instance, for traffic measurements based on his idea or what it should be. And what we have in mind is now the data-driven approach. So next slide, please. The problem with the traces is like they might not always be available. So this is a big problem for us for the research community, like Google, Facebook. They have the traces, but we don't see them. We don't have them available, so we cannot test with them. But of course, if we then look in their papers, what we see there is like they have models. The problem with models is always it might not generalize well, and it's also not covering what can happen in the future, or it's also maybe not covering the extreme cases. And the third part is even that sometimes what we have also in research is people are proposing algorithms, and maybe they are just taking some points that are that look there like shiny. So they design the performance innovation in a way that it's good for their solution. So what we thought is like putting also using machine learning in a different perspective. So taking the data-driven approach. And this is also, again, what this talk is about. So we want to use machine learning or artificial intelligence to benchmark networks. So next slide. This is a kind of the traditional chain. I mean, we have the benchmark instance generator, for instance, for protocols, for algorithms, for routing algorithms. You're generating problems like routing from A to B. So we have the problem instances. This is what we then feed into our solutions, like network algorithms and functions again. And then the algorithms or the functions, they are behaving in a way that we get the problem solution. So this is the traditional way. So next slide. What we have already done over the last 3 years is to think about where to integrate or how to integrate machine learning, artificial intelligence there. In particular, what we are doing or what we were doing is like we want to learn first from the problem instances. So this is like when you're doing this classical traffic analysis and try to identify how the traffic looks like or how the problem instances actually look like. So where do we have our routing request? How does our demand matrix look like? And then, of course, when we are continuously solving problems, we can somehow get some information from there. So we can also see like the problem solutions and combining both the ideas that we can help existing systems, network algorithms also here to identify problems and so on. This is somehow work we have already done over the last 3 years and published on some workshops at SICOM and in some journals. Now, our way different to that is on the next slide. And this is what we think now where we can also plug in machine learning. So the idea is that we have on the left side where we are generating the benchmark instance, where we are generating like the traffic, where we're generating the problem instances, that we can also plug in machine learning, artificial intelligence, because we can also, again, take the problem solutions into account. And then thereby what we would like to have is we would like to generate adversarial problem instances. So we want to have problem instances that are challenging our network algorithms, our functions that help us as engineers, as researchers to identify really, again, weak spots, and thereby also to then know where to look for, or let's say to identify weak spots and then develop the solutions. There was also one point mentioned like about the data. Because the data is not always available, this approach should also help to overcome this a little bit in the sense that we should find ways to generate data that helps us really to benchmark our systems So we see a lot of potential here that this is another part of the let's say AI or ML chain, what we need to put here. And the overall idea is then that we have maybe in the end machine learning AI versus machine learning AI, but you can also say maybe machine learning AI versus the human as a developer. So when you're doing your testing, when you're doing your integration tests, when you're like you're not testing and just versus like unit tests for software, but you're also testing against a machine that is generating input for your programs automatically. Okay, so next slide. And this is an example that we used in our paper. We use the Open vSwitch because it's still a very prominent software. It's in the products of VMware, of course, not like the open source software. And then we had a setup with 3 hosts. And in this simple setup, really, we just had a host that was generating the network traffic on the left side. And for the generation, we had the configurations, and we had the host on the right side where we were sending the traffic to. And in the middle of this, where we were running the Open vSwitch, we were just monitoring, for instance, the CPU utilization of this Open vSwitch, but we were also monitoring the latency. So we took these 2 metrics into account in order to benchmark our system. And the task of the Open vSwitch in this case was just simple. There's just one rule for forwarding the packets, and the rest is about dropping. And you have all these this kind of setting everywhere. I mean, if you have firewalls, if you have simple forwarding rules on hypervisors where Open vSwitch is mainly running, this is something you can see there. And the goal was then to find a network traffic configuration that actually maximizes the CPU latency in this case. So on the next slide, please. The point is that, of course, this is all what we know, that it's not so easy actually to generate network traffic because the configuration space, it's huge and complex. It's coming simply from the number of packets you are sending over time. So you can just decide to send between 1,000 to 5,000 packets and see what does it mean. Also, how do you send the packets over time? So what are the batch sizes? So should you send 1 packet per time, or should you send multiples, so to emulate bursts? And also what should be the packet inter-arrival time? So should it be 1 millisecond, should it be 30 milliseconds, so on? And then when you go to the protocols, you can say which protocol should you use? Should you do a VLAN tagging? Should you use it? And the point here, because if you just think about the poor header, you could say that you have opportunities like options 2 to the number of many bits. So here still the human is somehow involved. So we also believe that the human cannot replace completely. We still need to start somewhere, and without like the human also being in this loop, it would be it might be quite hard for the machine to find anything. So the human still needs to set this. And these are also the parameters we then used in our evaluation in this scenario here. So next slide.
Yeah, you have 2-3 minutes to conclude. Sorry, we have.
Yeah. Okay. So what we have here is the measurement loop. So we have the traffic generator, we have the Open vSwitch, we have then these measurement points, and thereby we are automatically learning actually the performance model. And this is the whole measurement loop. So next slide. In the end, what we want to have is the black box is the Open vSwitch, and we want to know how the performance model looks after measurements over time. So this is what we are doing continuously. So next slide. What is then happening is, as you see here, there is a belief in the performance model. In the first iteration, it looks like that there is no CPU utilization at all for any traffic configuration. But when we have multiple iterations, we see how we can learn the CPU behavior of our Open vSwitch. This is what you see after like iteration 25. And you see also there that for some configurations, the CPU utilization is quite high. So next slide. And in the end, it's actually not trivial. So what we got from a grid search is that setting specific network configurations, you have really drastic difference in the CPU performance models. So when you look at the 2 crosses on the next slide, what is interesting here that, for instance, when you send 5,000 packets with an inter-arrival time of 1 millisecond, the CPU utilization is quite high. When you're sending 4,000 packets, that the CPU utilization is quite low. So when you're sending 4,000 packets, it's much higher. And it just depends on the inter-arrival time of the packets here. And what is surprising here is that sending actually less network packets over time leads to a much higher CPU utilization, difference of more than 20%. And why is this happening? This is what we see on the next slide. The point about the Open vSwitch is that whenever you're sending a rule that, for instance, a packet, it's inserting a rule for this packet. And when you're sending packets from multiple, for instance, IP subdomains, then it's inserting rules for all these subdomains. And there's a timer for these rules because the space of the rules is not endless. That is always refreshed. And this timer in OVS is set to 10 seconds. So next slide. So what is happening if you're now sending the packet just after this timer is that before the timer the timer triggers that we remove the rule. So the Open vSwitch is going through the data structures, removing a rule. Actually, in this case, going through n like entries. And then slightly, if you're sending network package slightly after these 10 seconds again, then it has to insert these rules again. So thereby, we are always triggering, for instance, with 5,000 packets every 2 milliseconds this operation. And this operation is a very costly operation in the Linux kernel, of course, in this setting with a megaflow cache enabled for Open vSwitch, which is leading then to this high CPU utilization as what we have seen before. So next slide. So what we can finally see here is NetBore in action versus, for instance, a random search. And the interesting part is that a random search is still somehow the state of the art. NetBore is for 1 to 4 network configuration or traffic configuration used here, always faster and always better. And more interestingly, after even like 50 iterations, so when we are continuously measuring, for instance, our Open vSwitch, we have already a 24% higher CPU utilization. And we thereby could somehow discover this weak spot in our implementation of the Open vSwitch. So next slide. This is actually now where you can already conclude. So what we have, the idea is that we want to generate or that we want to have adversarial inputs to find weak spots or security holes. And this should help us to make our systems more bulletproof. And the idea is really to use concepts like NetBore to receive continuous feedback about solutions and implementations. The use case is here. So we use the Bayesian optimization-based data-driven approach to generate these network traffic configurations. And what we saw is like that we can find these challenging traffic configurations very efficiently. And we can use it to either maximize, but also to minimize like CPU latency. The open questions we still see is that, of course, does beating actually the machine means in general that it generalizes? Also, does it scale? Or what are the alternatives? Because, for instance, Bayesian optimization itself, so machine learning itself has also configuration parameters which you need to tune in order to make it efficient. So next slide. These are the references on the next slide. I just would like to thank you and would be happy to answer your questions.
Thank you, Andreas. So any question? So, yeah, one question.
Actually, I have a comment, but Dejan Bogdanovic, this is really interesting work, and I saw a draft from Comcast that was rating some of the questions and requirements that you're answering in your work. And I was just trying to find out what is the draft to point you to that, and you might, then work on this together in the IETF. Thank you. I'll put on the list.
Thank you.
Okay. So thank you, Andreas. We have to move to the next presentation. So thank you again for joining early this morning in your home. Will, can you come in front?
Hello, everyone. This is Will Liu from Huawei. So today, I'm glad to present to you about the progress and status of SC-ISG-ENI. So this is a group activity active in SC. Next. Yeah. So basically, given the time is so limited, I only have 5 minutes for presentation. So please ask a question after the presentation. I have 3 minutes to answer your question. So I will go through by first about the value and the vision, second about the status and progress, and also introduce some of the other activities we have already done. So basically, I guess, given that I'm not the first time to present this, actually, I presented this about the progress and status 1 year earlier. So I think now everybody are almost agreed about the business value of network intelligence or network AI, given that the network becoming complex in terms of protocol and management. So we really need the AI to assist the human beings to do the configuration, operation, and management. So we figure out that we can achieve better network experience for both the operators as well as the enterprises, and also for the 5G IoT perspective, QoS or QoE perspective. This is all helpful. So well, I've listed the actually this is the charter similar to IETF or RTF group that this ISG was founded in 2017 February, and at the very beginning it focused on study the use cases about how do we utilize AI to network operation and management, and we propose that we may add in closed loop AI mechanism, and based on the context-aware, metadata-driven policies. And also, besides use cases study, we also have generated a abstracted architecture, as well as we have some POCs ongoing, and I will explain that later to you. To be mentioned that in early this year, so the ISG extend its lifetime to another 2 years, and we will continue about the POC, the reference point, and some other activities I will explain you to later. So this is a one page in a nutshell about the ENI summary. So on the figure, you can see that we already have more than 50 companies joined us, including 14 operators. And we have official teams and the POCs review teams from operators and vendors and research institute. We already studied 21 use cases in 5 big categories. For example, we have infrastructure management, network operator, and network security related. So I'm sure that if you want to look at the use cases, and this is the right place that you can find enough use cases that might be useful for your network. And also based on these use cases and the requirement related to that, ENI already started 6 POCs. So each POC is supported by one big operators and including vendors and research institute. There are already 3 completed, and I will explain one in later slides. And beside those ones, I've listed all the ongoing and finished work items, meaning like drafting our IETF. So we have use cases requirement and terminology framework. And recently we have categorizations and data mechanisms work. So already published the 6 work items and 1 white papers. And this is because I already mentioned the use cases. So this page gives you a very quick glance about the requirement and the architecture, given that I have so limited time. So if you want to know the details, I have a almost 100 page of slides to explain you in detail. So for the requirement, we categorize the requirement into 3 different categories. So this is service network requirements, functional and non-functional requirements. And for the architecture, what I showed in this screen is a very abstractive, high-level architecture. And we also have a detailed with reference point architecture in the document. And also we have 3, actually it's 2 mode and 3 ways of the applying the architecture to the existing network system, including NFV and other architectures to get aligned with. And this is another work that we just published in this month, is about the categorizations. We learned a little bit about from the vehicle, autonomous driving levels designed by SEA from America. And this is the way that we can categorize the level of the AI applied to the networks based on different parameters. And this is the POC number 1. It's called Intelligent Network Slicing Lifecycle Management. Basically, we do the prediction based on the traffic pattern, and we adjust the network slice according to the result. And we already demoed this in different events, including the latest one is in HAG, SDN Layer World Congress. And those are some other activities that we have workshops and forum and some joint conferences with other activities such as Europe project or some research activities. And the next meeting will be next month in France, the headquarters of ESSI, and you're welcome to join us. And the ENI already sent a liaison last year, and we will probably send a liaison this year to NMRG, and we hope that we can jointly, work together and to create more useful and practical, valuable deliverables together. Thank you. And any questions? Okay, if you have any question, you may contact me offline. My email is here. Thank you.
Thank you. Thank you, Will. So next speaker is Laurent.
I'll present a bit the link between ETSI's LSM activity and the work that could be done in NMRG on artificial intelligence. ETSI's LSM is not a standardization group doing per se artificial intelligence for networks, but it's more around self-managing and zero-touch network management, network automation. And in that space, we are using some artificial intelligence techniques. For the sake of time, I will browse very rapidly over this slides, but if you want, you have some information about the ISG that is currently running. This is the LSM architecture. So it's a management architecture, service-based, service-oriented management architecture. And you have a set of different set of services, management functions, especially for the registration, for controlling resources, for orchestration. And I will make a focus on specific set of services that are, we think, relevant to AI in network. So in the currently defined set of services in the architecture, what I try to highlight in red are the set of services typically of interest for doing AI in networks. So we have data collection, analytics, and intelligence. This is the terminology we're using in ZSM. So you have it per domain or end-to-end. And you have also at the bottom right, in the dashed line, data services, which are typically the infrastructure for monitoring and telemetry. So going into just a few details about those groups. So domain analytics, this is where you can get together all the services that will realize processing over some data. So the domain analytics provides domain-specific insights and generate domain-specific predictions based on data collected by the domain collection, and also data that can be from other sources. This is in support of different types of analytics. So you can generate some insight, understand what's happened in the past and why it happened, insights and foresights also to be able to predict future events for the network. So this is also known, if you see the other terminology, for analytics, descriptive, diagnostics, and predictive analytics. The prescriptive part of analytics, this will be more handled by the intelligence domain. But just to summarize, so in analytics, we have a set of services. You take data in input and you try to generate some insights in the output. Domain intelligence, this is where you have services responsible for driving the closed loop automation. So this is in support, by supporting variable degrees of automated decision-making and human oversight. And we aim for fully autonomous autonomic networking. So this is to highlight a bit what Will was mentioning with the different levels of autonomy in networks. You have typical category of types of what the intelligence services can output or can be used. So for decision support, for decision making, or for action planning, this is try to highlight a bit. You have different forms of AI, either to learn on data, but also to reason on data, to make plans and decisions, and also to handle the aspect of knowledge management and knowledge returning. So the decision support services enable decision making via technologies such as artificial intelligence, machine learning, and knowledge management. So this is where we see with domain analytics and domain intelligence, where we will have use of specific AI techniques. Again, in ZSM, we will not design such techniques, but we will provide kind of agents or services where you can plug the different intelligence mechanism and make them use in a more general self-management architecture. And finally, data services. This is a kind of common layer where we have data services provide means of data persistence and enable data sharing between the different consumer of data. So essentially domain analytics and domain intelligence across the management domain. So this is a kind of reusable mechanism that any subscriber to those data services can have to collect the right set of data. We think this is a key enabler also for fueling data analytics and intelligence, because as we have seen in the previous presentation, access to the data, to the right type of data at the right place, also extending with metadata, this is essential to be able to perform useful machine learning and AI algorithm. Another area where we see the application of AI in network management, this is another part of the ZSM activity, is on closed loop. So in ZSM, we are working on designing and providing to provide interoperable closed loop components. So not the closed loop as a whole, but at least the different parts you see, like observation, orientation, decision, and action, to provide these as standard components, the interfaces outside of the standard components, and so where they can use also some parts of intelligence. So you can see that, for instance, the analytics and intelligence services will be reused as part of the decision process to close the loop in such a representation. So that's all for this short presentation. If you want to look at the architecture, this is a published and public document, and we are also working on the so-called closed loop documents where we will have more embedded use of AI.
Will from Huawei. So this is not a question, actually, it's an addition point, is that ENI and the CSM will have a co-locating meeting together in December. So if you're interested, you can join us to get this action. Thank you.
Wait.
Yes, so we continue the next presentation, and it's still Laurent.
Yeah, for ZSM, I'm participating in ZSM group. This is another group, not a standardization group. It's called, it's an emerging technology initiative in IEEE ComSoc called Network Intelligence. I'm here representing this technology initiative on behalf of the chairs, the officers, because they could not make it, especially due to the time difference for remote presentation. So ETI-ENI, it's kind of placeholder or community where you to encourage research on network intelligence to happen from the IEEE point of view. So it's a new community, rather new community initiative focused on network intelligence. It was approved by CONSOP December 2 years ago, and it has been renewed again. So it inherits from previous technical committee in IEEE. There have been some reshuffling that were targeting autonomic communication. So we built on top of that, and we had also a new view, a new vision of what network intelligence could be for networking. So quickly on the mission. So this kind of technical committee in IEEE are here not to actually do the research, but to foster the research to happen. So it's in support and to endorse research towards embedding artificial intelligence in future software-defined and programmable forwarding planes. So the aim is to support and endorse and enable faster deployment, dynamic provisioning, end-to-end orchestration, high resiliency and availability. So you have an idea of where we can see this AI technology to be used and to make benefits. In the kind of description of the topics of the ETI, there are a set of topics that are, it's not limited to, but we wanted to highlight key areas of interest for this group. So related to, for instance, intent-based networking, which can have also a home in NMRG, use of different learning techniques and how different learning techniques are useful or needs to be used or could be used in networking environment, resource allocation, relationship to self-management and autonomic types of networks, learning and reasoning techniques. So you have a set of different topics, and it's can be continuously evolved. This is just to highlight the responsible of this ETI. So this is just a role to organize the group, not to steer the group, in fact. So if you have questions, you can contact any one of those officers to join the group or to propose activities in the scope of this ETI. The participation is open to everyone. It's not very costly. There is a website, a mailing list, so you can subscribe to the mailing list. And on the website, you have all, I would say, relevant information. We try to keep it very up to date with the different events, workshops, special issues, data sets that have been brought by the community so that it's still always relevant in terms of timing. A quick view on some ongoing activities. So since it's already 2 years old ETI, we have already in the past done some workshops, special issues, but to show a bit the current activity, there will be the third international workshop on network intelligence, which will be co-located with IEEE Infocom conference next year. So this is the second time we co-locate with Infocom. Last year was very successful workshop, and it was also ending up with a special issue in a journal. So we still have time to provide a contribution to this workshop. There will be also the third AINet conference, which is co-located with the MPLS World Congress in Paris. This will be first quarter next year in Paris. You can still provide some abstract if you like, but the program is nearly closed now. So ETI is also supporting the organization of this conference. There will be also the third Applied Machine Learning Days, which is a very broad machine learning type of conference in Lausanne. And we have there a dedicated track on AI and networks that we co-organize with some of the officers and other members of the ETI. This will be end of January in Lausanne. It's a great event if you want to know and to connect with people working in machine learning, but this is not network specific. You have AI for multiple domains application. We are also active in some standardization activity, especially what we do here in IETF and also in connection with NMRG. But as you have seen, there are also people in ETSI, in different groups, and in IEEE. We are also working on a set of different future special issues, so you can have the information on the website of the ETI. Then, to conclude, a very important aspect that I mean we have learned through working in this ETI also with the members and different studies that have been reported. It's on the so-called network data, a key activity area for this ETI. Network data is characterized by a high dimensional space. We have hundreds of thousands of dimensions to consider when we run the models. Numerous set of KPIs or measurements and counters to track. So this is not like in other fields, a very, I mean, simple area. It's very a multitude of different data to track. The data also in network is very heterogeneous in the different segments. You can go into very different types of data for the same thing in different access, in different segments, like the access, the core data center. Also per topology related to these different segments, the shape of the data is organized quite differently. So it's also a challenge when you want to organize your data. The variety of the types and formats of data is also huge. You have logs, different types of logs, metrics, alarms, trouble tickets, KPIs, configuration files. So the variety of what are the data is also very huge compared to other fields. And so to have an organization of those data to be able to be exploited automatically by artificial intelligence technique is a huge effort, a huge preparation effort, just before you enter into the real problem of solving something with AI. So I think this is, I will not say that in other field it's not this way, but I think in network it's very, very important dimension. And this is a very big challenge in, I mean, to the very large adoption of AI and having more powerful results also. So network intelligence, ETI tries to make this aware in this community and so that everyone in the community can work towards this network data challenge to exchange practices and knowledge, and so to bring together these data science challenges for network data. I think that's the last slide.
Thank you, Laura. Comments, questions? So I have one for my side, so Jerome as an individual. So yes, I agree on the last slide with the network data, it's a challenge, but there are multifaceted problems. So what is actually the role of would be the action of ETI in this regarding this key activity area as you mentioned?
So far it's not organized. We don't have clear path or roadmap how to handle this key activity, but at least understanding that this is a key challenge was the first step. It was reported for a set of activities by different members active in the group, what they have done on data with operational networks. So they really had work for a couple of years to collect different use cases and try to not only work on the use cases, but take a step back and say, what have we learned? What were the challenges when we have worked on these use cases? Not to solve the use cases, but to get the data, curate the data. So everything that was preparation work for before actually solving the case. So, and this was just like knowledge, and we want to share this first understanding of what the challenges is. How we organize that in the ETI, it's still up as a next point, as the next step.
Go ahead. Dan Bogdanovic. So when you say labeling network data is a huge effort, I believe that we today have basic sets that are people already following and using that as a starting point and try to create a classification of that could be helpful, would be a good starting point. Because in my conversations with network operators, especially the network operations center people, they're saying these are important things to us, for this areas of the network. And at least it gives you some starting point. When I was my whole life a vendor, trying to get everything and guessing what is really needed, what is useful. It's it's like a bingo, and trying to take that and use as a starting point for further evaluation might be a good idea. It would help, focus the research area.
Thank you, Diane. I fully agree with what you say, that categorization on the operation side is essential. And it's a multi-level effort, because this is kind of one hand of the problem, but also understanding the diversity of what is being collected. And to understand, I getting data, I don't know what the data is, or how I can use it to reach to the operation, the use in the operation. So this is quite challenging activity. Diego?
Diego Lopez, I work for an operator, but I have no idea of what my operation guys do. So I'm not doing. But that's the problem. They don't talk to me now. Seriously, the point is that I think that is for this, and we have started some small effort that I hope we will be able to report in Vancouver, or very likely Madrid, because the people working there will be working on this, will be closer. It's precisely about data source description framework. So what you can is you can use some metadata formats to tell what you are expecting to collect from a particular data source, or what that data source can provide. I think, I don't know, I'm not aware, and I'm coming here is, do you know if the ETI is considering to initiate such an effort, or is just...
No, I don't know yet. I mean, this essentially this network data is reflecting some activity that, for instance, Eman is doing in Orange.
Sorry, we have only takes one question more after, but then you have to get okay.
We can discuss after that, Diego, if you want to know what could be the next step for that. Sure.
I think Dean wanted to add something.
Yeah. Hi, Nalini Elkins. One thing that I've done for quite a while is work with operations people at large brick and mortar enterprises. And one of the things, there's two movements that I see that are very much at cross purposes. I think trying to collect network data and have network intelligence, I totally support that. But with all the encrypted protocols that we have, and the push towards only being able to see, of course, packet level data, but also metadata only at the endpoints, network-based intelligence becomes quite challenging. So do you have thoughts around that?
Okay, so me personally not, because this is not an area I'm looking into. One part of the answer I can provide from my experience is at least part of what we are doing here is not always used on user data or data traffic. It's also mainly on management types of data. So even if it's encrypted or using authenticated communications, we have access to some of the data. I mean, the logs, for instance, the configuration files, these are not in the user plane. It's more from the operator use of data. So this is more AI for network management. I know there is AI for network in general, but to answer your question, I know maybe Jérôme has more insights on that, but this is really not my field of expertise. I cannot really comment properly on that.
Sure. Yeah.
Okay. I think we have to move to the next. Sorry. So now I think Vishnu is next.
Good afternoon. Can you hear me?
Yes, perfect. Let me just put your slide. Okay, great.
Thank you so much. My name is Vishnu. I am here to give an update on ITU's work on machine learning for 5G. You see my email ID there. In case you have feedback questions, you can write to me. And this is the website below is the focus group website for machine learning 5G in ITU. Next slide, please. This is my agenda. I will give a quick background. There is an update of work items in ITU, which is some of it finished, some of it ongoing. And there is also, I will talk about network AI challenge that ITU is planning to do. And there is an update on students projects, one of the initiatives that ITU is currently launched. Next slide, please. This is an update on current status of ITU's work on machine learning for 5G. The work items which are finished are here. There is machine learning in future networks, including IMT 2020 use cases. This is approved. This has been derived from a large set of contributions to the ITU. We have collated it, maybe tuned it and polished it, and now it is approved as a supplement 55 to Y.3170 series. It is currently in editing process and it will be published in a few weeks. It will be available for public access. You can access it via a guest account. Even non-members of ITUT can access it. In fact, once it is published, you can access it through internet, Google. The next one is architecture framework for integration of machine learning in future networks. So this is published already as Y.3172. It is available free of cost. So you can download it from our website. The framework for data handling to enable machine learning. This is now currently in ITU approval process. Y.3174 is the number. You need an ITU account to access it right now, but if you once it is through the approval process, it will be published and it will be available again freely publicly. We also did some work on evaluating intelligence level of future networks. This is in ITU approval process. It is Y.3173. Next slide, please. Just wanted to give you a quick update on the architecture framework. I don't go into a lot of details, but I want to call out some important parts of the architecture. You see, it is published already, as I told you. Y.3172 is available already. I go from bottom to the top. We give underlay network concept, which on which we run the machine learning pipelines. You can run multiple of these in the underlay networks. For example, 3GPP could be an underlay network for us. IMT 2020 architectures, any of those could be an underlay network for us. ML pipeline gives us an abstraction for machine learning. How do you run different types of collection data sources and applying machine learning in the networks, what are the input and output and models. This is abstracted by this machine learning. And we heard from Andreas earlier about testing strategies. Sandbox gives us an environment to test and verify machine learning. It hosts a simulated ML underlay networks. You can read the details in 3172. On the left side, we have function orchestrator, which manages the machine learning functionality in the network. These are the main concepts that we have in the architecture framework. Next slide, please. This gives us the work items in progress, ongoing, optimization and deployment framework for machine learning models in future networks. This is ongoing as ML5G 171 document. It is freely available. You need a guest account from the ITU. You can create it in 5 minutes. ML marketplace integration in future networks. This is to address the need for some of our operator members who wants to host a machine learning marketplace integrated with the existing marketplaces as internal or external marketplaces. Once again, this is 167 document, and you can download it free of cost, and it's work in progress. Requirements, architecture and design for function orchestrator is also in progress. Next slide, please.
Yeah. Vishnu, you have 1 minute, please.
Thank you. These are the lessons and collaborations. We collaborate with ISO IC on MPEG. Linux Foundation, we have some projects running on model optimization. You heard from HCNI earlier. We have official as well as collaboration going on with HCNI and ZSM. We also collaborate with ORAN on machine learning metadata, and as we speak, SA5, 3GPP SA5 presentations are going on similar to this. We have next meeting coming up in March. Weekly conference calls are open, and you don't need to be a member to join these. You can contact me or use the website. Next slide, please. About the AI challenge, ITU is planning to run an AI challenge. We are looking for partners. There is a set of open data which is published to us, which is here, and also details are worked out. We can discuss offline. Next slide, please. This is a unique initiative. ITU is offering guidance to university students. There is a web document which handles it. I coordinate the project. In case you're interested, please contact me. We have about 4 to 5 countries right now collaborating with us to run these projects. Next slide, please. These are the references, as I told you, some of which require a member account, but I have given you corresponding free documents as well, which you see here in brackets. You can use either of these. That's it. Thank you so much.
Thank you, Vishnu. I think we have to continue with in the next presentation because we are running out of time. So thank you again, and also to provide all these link to documents and so that people can access and can read it, and then can continue to talk with you per email and so on. So thank you again, Vishnu.
Thank you.
So next speaker is me. So I will talk a bit about the network AI challenge, or AI network challenge. We don't have a name, but anyway. So as you may have read on the mailing list, we are starting talking about what could be a dedicated challenge, AI challenge for networking. So there are some initiatives that we have seen before and that we'll see after in the next talk. So we are maintaining kind of pad to have where we could follow the different discussion we have. Basically, we have some more free work item is related to what could be the use case to having these challenges to be exploited. Then if you know the use case, you have to identify how you will run the challenge on this use case. So you need data, you need a platform maybe, and so on. And of course, then there is all the issues, or let's say the question of how you publish the challenge, when it will be, and so on and so on. I will go fast. So the first item was about the different use cases. So we are discussing different use cases. It's we don't have yet one or two use cases that we will do in the challenge that we will support. So this is more open discussion. So yeah, there is one use case of routing that I will really detail a bit afterwards, which is more related to IBM. Another which is more classical traffic prediction and so on. Of course, it's open to any discussion. So if you want to bring some things that you think it can be very interesting, we are very open. I will rapidly go through this, let's say, routing or forwarding and traffic engineering use case. So why we wanted to introduce this one? This is a very well-known kind of use case. So there is no, let's say, big fancy applications that will come out from this challenge. But the idea is that it can be very understandable by anybody, almost. I mean, so we can have people from other communities, from AI communities. I don't need to be network experts. I don't need, for example, to know what is the recent advances in network. The goal is just to basically forward packets into a graph or into a network. There is a rich literature in this area, and we have already discussed there. But basically, here the idea is that we would like to somehow, thanks to the artificial intelligence, remove routing algorithm in a network or routing table. And if you see what has been done for a while in this area, it's a lot of people have used reinforcement learning that you route packet over some interfaces or so over path or link, and then depending on the reward, you can adjust over time what will be the best path. That is what is very often done. As the idea here is that what could be a good new idea to try to exploit in this challenge is that even because if you have some reinforcement learning, this deep reinforcement learning, or let's say reinforcement learning in general, you need some reward. But sometimes you cannot know what is this reward because you don't have access, for example, when the packet arrives at the other hand. So of course you need at some point, because if you have no at least reward or no insight about what could be the right decision, even machine learning algorithm cannot do. But sometimes we could imagine some alternating when you know what will be the reward, and sometimes you don't know it, to find some strategy between the two, or if you can learn in advance in a kind of simulated platform, and then apply in a more, let's say, real operational environment, even it will be always on simulation. So we will continue because it's a early stage. We'll try to document this a bit more. So we are actively looking for volunteers to help and build this use case or other use case. Yes, with our other items which are more general, not only to this use case, so we are still working on what could be the platform, of course, depending on the use case. We are also looking to team up with other communities, for example, with MFIG has been presented before, or other potential communities. So the idea is that rather, the goal is not to have, let's say, an NMRG AI challenge. It's to have a network AI challenge that, to try to create a kind of label over all these kind of challenges that are related to AI for or by network or whatever, just that we can share the expertise, share our feedback all together, and also kind of maybe a kind of a public, I would say, a place that we can all advertise to each other what we are doing. And yeah, that's it for me. So if you have any comment, I don't know, Laurent, the time. Okay, so any comment?
Let's move maybe to the challenge from Albert, and
yeah.
If there are further questions, we can have them there.
Hello. So this is basically a proposal of a challenge that we are running right now. First, I would like to discuss a little bit what people do in computer vision, because computer vision is a very successful application of AI, and then we can try to learn what people in computer vision do, how do they challenge work, and try to somehow learn something from them and apply it to network machine learning. So typically in computer vision, that's very common for many challenges. What they do is the organizers, they provide a data set of with the data has labels, meaning, for instance, this can be a data set of pictures where each picture is labeled, like, okay, this is a car, that's a tree, that's a chair, that's a pedestrian. And then the participants, they take this data set, and what they do is they submit neural networks, meaning that they build neural networks on their own, and they try to build the neural network that can better understand the data set. And then the organizers, they take all these neural networks, and they evaluate which one is able to model the data set with more accuracy. And then they rank all these neural networks, and they decide who is the winner. Okay. Typically, on the third step, what you do is the organizers, they have they evaluate the neural networks with a data set which does not have labels for the participants. So they don't see which are the labels, and they cannot do like fitting too much the data and so on. But this is the general approach. And this is like a set of list of a huge amount of challenges that there are regarding computer vision, and some of them, they are quite prestigious, particularly the one organized from ImageNet. So the challenge that we're organizing, we call it Network AI Challenge. It's a very, you have the URL where you have some more additional information, and the plan that we have is the following. So it is true that it is very hard to obtain real data from real networks. As far as I know, no one has been successful, and then it's a chicken and egg problem. Then we cannot organize the challenge, and we cannot, if we don't have data, we cannot start working on real machine learning, because it's impossible to build a neural network without data. So what we have done is we are using a network simulator, which is OpNet. It's event-driven. It's per packet, meaning that each packet is simulated in a network. And what we do is a quite simple label. We take one topology, one traffic matrix, a realistic traffic matrix, and a network configuration. We simulate it, and we generate the labels, which the labels is, okay, for this topology, this traffic matrix, and this network configuration, I'm seeing this performance of the flows, like this delay, this jitter, and these losses. Okay, so it's very fundamental to computer networks. It's like networks 101. So this is the data set that we are producing. So we have, as I said, each row is network topology, network configuration, traffic matrix, and the label is the performance of this traffic using this configuration over this network. Okay, so basically we have like around 60 gigabytes of data, because we need to run many topologies with tens to hundreds of nodes, then iterate over many random configurations and many different traffic matrices to generate all these labels. And from a previous paper that we have, you can see the data set. It's like around 60 gigabytes. And now we are generating a new one for this challenge, which is being generated right now. But in the URL below, you can see the one that we had for the other paper. And it's basically this. We are also providing a Python API for participants to have faster access to the data. Then what is the challenge? The challenge is, okay, given this data set, you have to build a neural network that, given an unseen network topology, configuration, and traffic matrix, is able to estimate the per flow delay, jitter, and losses. So I will provide you a training data. And then what you have to do is, if I give you a topology which you have never seen, with a configuration that you have never seen, and a traffic matrix that you have never seen, meaning that it's not part of the training data, you should be able to estimate which is the per flow delay, jitter, and losses. Then something which is also very common in computer vision is that organizers or the community at large, they provide a baseline, meaning that there is some sort of neural network that it is able to provide answers to this challenge, even if it's very inaccurate, even if the accuracy is not very good, or even if it's not working very well. So what we have as baseline is RoundNet. RoundNet is a graph neural network which is able to generalize to unseen topologies, traffic matrices, and configurations. And you can see in this paper the whole architecture is open source, so participants can take RoundNet, and that's very important, and that they have a baseline to start working with. They don't have to start from scratch, and you will see why this is important. So if you take RoundNet, vanilla RoundNet, and you don't do anything, and you just use it with a new data set, what you obtain is a mean square error of 46%, which is quite low. So typically, you should expect a mean square error of close to 0, right? And why this is important? Because, in the target audience, you have typically two people. Either people that are purely data scientists, that they don't know anything about computers, and maybe they don't care. But what they want is to take this open source code, this TensorFlow code, round it, and try to do their own tricks and try to increase the accuracy and the precision of the model just by using purely data scientist tricks. So that's why it's important to give them a baseline, okay? And there are many people doing this kind of stuff. Maybe they do some hyperparameter optimization and so on. So with this way, we can bring people from other communities to networking. The second type of target audience is us, of course, is people working computer networks and network AI, which they can take the data set, they can understand what is a network, they can understand what is a graph neural network, and then they can try to do something which is way better than what RoundNet is today. So then I'm not pro this, but we are considering at least. But so far we are not. We have not decided to do some use cases. But for instance, a use case could be find which is the optimal network configuration given an unseen network topology and traffic matrix by means of a neural network. Yeah, sure. So the dates, tentative dates is dataset should be available in spring 2020. Then participants, they should submit in the summer of 2020. So typically it's 2 months from the data is available until they can submit the final solution. And then the award will be given in 2020. We will use this kind of dissemination channels. This is the target audience that I was discussing before. The academic paper is that after the award, we plan to write an academic paper describing how did the challenge went, what did the participants do, co-authoring with all the participants. That's typically a sort of a reward for the academic participants. And that's pretty much it. This is the kind of questions that I have for the working group, for the research group. I don't know if these use cases are relevant. Any other volunteers to co-organize this? Is the research group interested? And so on.
Yeah.
Yeah.
Okay. Thank you very much, Albert, and for presenting this practical network AI challenge. We are looking for that. Of course, I mean, NMRG is really welcome to have this challenge, to give you a space if you need for presentation, for advertisement, or you can work with us for that. You are very welcome, and you are part of the community anyway. And also, I would like to raise more towards the research group. I mean, how can the research group help you? Or if you need to something, you can maybe send an email to the mailing list. And if people in the room are really interested into that, please go to Albert or to us, and we will make the connection.
Okay. Thank you.
Okay, so the last presentation is just to give you a kind of a summary of the side meetings that we have done on AI on, I think it was on Tuesday, so with the people listed here. So it's just not only my view, but it's just kind of a summary of what has been highlighted there. So just because we don't have so much time, so the key point, that the objective of this meeting was to identify the challenges of using AI in our domain, in general, let's say network. So what makes the use of AI different in our domain compared to other domain? So just to find the specificities. So we go through some discussion, and it's what basically remain after this discussion. So there is probably some challenges regarding lightweight artificial intelligence. So even if at the beginning it's not really specific to network, of course, you can think that you may have lightweight devices in network, or you want to have more, let's say, AI in the network. So of course, this is also related to what happens in coin energy. So that's what has been mentioned there. And then it's also related to all the distributed artificial intelligence, swarm intelligence. So the idea is also here, the network is not only a user of the AI, of course, but also can help to support more efficiently the AI to synchronize between maybe the different agents and so on. Those are challenges very classic. I think we told a bit already about this data challenge, I would say. Of course, there are different problems with the data. So you don't have access, are not representative. So we have also a technical presentation today, how to generate more data to assess a system more globally. So all the data problems that you cannot access to the relevant data, in particular in when you compare it with the learning environments, operational environments. So it might not be possible to make generalization easy. So there are different research directions that we identify here. One is to have more, let's say, consensual description of the different data we use. Maybe another one is also to use AI to generate the data, as we see in another talk, or to maybe also look at what how to transfer knowledge from one domain to another, because if you cannot access, it's the data you have in the different, let's say, environment from where you do your learning, your learning model, and when you apply it, because they are not the same people working on that, it may be good to know how you can make some transfer, because there are some, of course, work on that aspect as well. And although the data is also not only thing, as we said a bit before as well, not assume that you have the data, but maybe based on what you want to do, identify the data you want and check what could be used or what is needed to access this data. Another point is what we call the problem challenge, or what I call maybe the problem challenge, is to find to see what is the right topic for AI in our area. Kind of mapping between the problem you may have and the algorithm you would like to use. One possible direction is rather than having a one-to-one mapping, try to describe with some attributes the problem we have in a network management or in network. And with the same attributes, try to, or different attributes, the AI algorithm, because you can have some characterization of the different problems from one side and solution from the other side, and then try to find a mapping. So it's not a one-to-one mapping between one algorithm and one use case. It's more a mapping that you will do over the attributes. So it might be more general. Of course, there is always this problem of explainability of the result of AI, because maybe the different experts from network and AI are not the same. So AI must not be complex to use. You may want to understand why the AI, your algorithm has decided to do that or that in your, let's say, configuration, for example. And it should not introduce some overhead, because if AI is another tool that is will provide other, let's say, data or another dashboard, it's not very useful. It's just an overhead, and it will not work. What happened is that, okay, we know that network problems are complex, not only network problems, but network problems are complex, various, distributed, and so on. And we know that a unique solution cannot fit all, right? So there are different ways to approach AI, let's say, a solution for a network problem. So the one is to think about different level of AI for actions, for AI that will recommend or that will guide human people, kind of assistant. And then also you can think about related also to monitoring and also how you will use the data. Try to see that just try to decompose as a problem is small piece, and just try to orchestrate all these small pieces. So more on the level of the orchestration. No, we are not really we don't think that we have to target to have specific AI algorithm, of course, but more on the how we can use it and orchestrate all together. Also with telemetry, for example, as well. So step to progress. So the idea at the end of this meeting is it's good. We have always these meetings that we discuss a lot, and we have even not enough time to discuss what we would like to continue. So the idea is that we will do let's say a public document, but written documents, report and documents that will first highlight what are the challenges, as we started before a bit, but of course this needs to be refined to be more discussed. So that will be help to clarify also the position of the artificial intelligence in an NMRG group, if it has to have a position here. And so we need, of course, diverse input for that. We need your help, and your help is just not only providing feedback. So I will ask you now, but also send on the mailing list. We really need people really wanted to contribute, write this report with a kind of course, a team to work on that. It should not be only 1-2 person writing this. So, and that's it for me. So I think we are 1 minute.
Well done, Jérôme, to catch up with time. Any quick feedback on the general discussion on challenges or the approach for AI in network management?
Okay, Xian from Huawei. Just one comment about the potential research topics. Just now, Long mentioned about the labeling the network data. I think is very important for us to have a discussion or have a thought about whether we can provide a universal or common data format for the machine learning, especially for the training, such as whether your training set can be used as my sample, so that it is very important for us. So unless we have a universal data set, data format, what we can do is you do yours system and I do mine. So our data cannot be shared. So this is a very challenge for us to do that. So that's all. Thank you.
Thank you.
Thank you, Jan.
May I comment a bit? Okay, so I think regarding the data format, yes, we may think about having some universal data format, and I think we already have some. But although that we all know that at some point we will have to deal with different data sources, and so it will be hard to say that we will have always this data format. So I think it's good to keep that in mind, because we should try to maybe to aim that. But in some points that appear in the discussion, rather than just saying that we will have universal data format, at least, universal kind of universal description, or ways that all of us can understand. If you provide a new data set, that we can understand your format with some, to some extent. But of course, yes. And I think that's it.
We're at the end of the session. Thank you very much for being here, knowing it's Friday, last session of the week. It was a long week. Thank you very much for being in the research group. Please, if you have inputs on the mailing list or contact us, we need to understand what we would like to do in the research group about this topic. We will also discuss with the IETF chair to have a bit of guidance for the next steps, because we have been investigating this topic for a couple of years now. So we really have to make a decision how to continue. So your inputs are very important to know if you have interest also to contribute, and suggestions for that.
So yeah, thank you again for attending the meeting. Maybe just a quick question. Who would like to help to write this report on challenges for AI network? Can you raise your hand? Yes, right. Now really right. And then yes, maybe review. Okay, contribute to the challenge report, I would say. But there is different on the level of involvement. So thank you, and have a safe trip back to home. Thank you very much for the discussion we had.
I'm sorry, I didn't join it.
It was a bit fast.